All right, Class 10 ICSE students, I know that pre-exam pressure is building up, but don't worry, you are in exactly the right place. We're going to cut through all that confusion and lay out a super clear strategic roadmap to help you completely crush that physics paper.
So let's be real. The syllabus is just huge, right? And you've got limited time. It's totally normal to feel a bit overwhelmed. I get this question all the time. Where do I even start? What's actually important? Well, guess what? Today, we're going to answer that question once and for all. Let's build our blueprint for success.
Okay, so our strategy is something I like to call the inverted pyramid. Forget starting at chapter 1 and just hoping for the best. No. We're going to flip that whole idea on its head. We're starting with the stuff that gives you the biggest bang for your buck, the units that are worth the most marks. See, this isn't about studying harder, it's about studying smarter. It's about putting your energy where you'll see the biggest payoff. And here it is. Take a look. This is the whole game plan right here. Light, force, work, and energy, and electricity and magnetism. These aren't just chapters, guys. These are the heavy hitters. We're talking about the potential for like 75% or even more of your entire paper coming from just these 3 units. So mastering them, yeah, it's not just a good idea. It's everything. This is the core of our strategy.
Okay, let's do it. Time to dive into our first heavy hitter, force, work, and energy. This stuff is absolutely foundational, so let's get super specific and break down exactly what you need to lock down to get those marks.
All right, when it comes to force, we need to be like surgeons, super precise. First up, moment of force. You can bet you're going to see numericals on this. Then you've got equilibrium and the principle of movement. These are your theory questions, so you need to know those definitions backwards and forwards. And hey, want to know a super easy win? Just memorize the center of gravity for common shapes. That's just free marks right there. And finally, machines. You absolutely have to nail mechanical advantage and velocity ratio, especially for pulleys. They show up on the exam all the time. Okay, moving on to energy. And you're going to love this because it's actually pretty simple. You can basically boil this entire chapter down to just 2 main ideas: the law of conservation of energy and the work-energy theorem. That's it. But, and this is a big but, they're not going to ask you to just state the law. They're going to test you on how to use it. That means practicing the numericals is not optional. It's essential. If you can get the calculations right, you've totally got this topic in the bag. Awesome. 1 down, 2 to go. Let's move on to our next high-impact unit, light and sound. This is where we get into optics and waves. And you guessed it, we're going to be super strategic about how we tackle it. Listen up, because for the light chapter, how well you can draw is just as important as how well you can calculate. Seriously, you have to be able to draw and explain refraction, especially things like normal and lateral shifts. When it comes to lenses, the lens formula and those ray diagrams, they're practically guaranteed to be on the paper. For prisms, you gotta know deviation and dispersion. And last but not least, the EM spectrum. Don't just memorize the order. You need to get the relationship between wavelength and frequency and know a couple of real-world applications for each wave. That's where the marks are. Okay, sound. This chapter can be a gold mine for easy marks, but only if you're smart. First, the basics: frequency, amplitude, speed. Nail those definitions for those quick, easy 1-mark questions. Second, when it's time for the math, put pretty much all your focus on numericals about echoes. And for the topic of vibrations, don't get bogged down. Just zoom in on forced vibrations. That's the shortcut to scoring high here. And speaking of echoes, this is it. This is the key. This one little formula, V equals 2D over T, will solve almost every single echo problem you'll see. Just remember, V is the speed of sound, D is the distance to the wall or whatever, and T is the time it takes to go there and back. Get this formula, and you've basically mastered the entire topic of echo calculations. It's that simple. All right, you're doing great. Time to tackle our final powerhouse unit: electricity, heat, and magnetism. Now, I know this one feels big, right? It covers circuits, current, and even heat, but don't worry. We're going to break it down into manageable chunks. So for electricity, let's split it in 2. You've got the theory part and the practical part. For theory, you absolutely have to master Ohm's law, and you've got to be a pro at solving those series and parallel circuit problems. Then there's the practical side. This is all about the diagrams. You need to understand how fuses work, how that dual switch staircase wiring is set up, and what each pin on a socket does. These are real-world things they love to ask about.
Okay, now for magnetism, it's all about the magnetic effect of current. Know what it depends on, be able to draw the diagrams, and understand the basics of transformers. Simple enough? But now, heat. Lean in because this is a huge tip. Forget everything else for a second. You can focus almost all of your energy on just one thing: calorimetry. Seriously, if you can master the numericals for specific heat and latent heat, you've basically nailed the most important part of the entire heat chapter. That's a massive shortcut.
And that brings us to our final section, modern physics. I know, the name sounds kind of scary, right? Modern physics. But I'm telling you, this is one of the easiest, most predictable topics in the whole syllabus. Let me show you why. Think of it like a 4-point checklist. That's all you need for modern physics. Ready? Number 1, know your nucleus basics, like the difference between atomic number and mass number. Easy. Number 2, memorize the properties of alpha, beta, and gamma rays. Number 3, understand what happens to the nucleus when it emits one of those particles. And number 4, know the difference between fission and fusion and have one example for each. You do those 4 things, you've got this chapter covered. Okay, so we've covered what to study. Now let's talk about how to study. We've got all this amazing information, and now we can build a personalized game plan. And it all boils down to one simple question: what score are you aiming for? And here are your 2 paths. It's really straightforward. Path 1, you're aiming for a really solid score, like 75 or 80%. If that's you, then your best bet is to focus like a laser on only the important topics we just went through. Mastering those will get you there. Now, path 2, you're aiming for the top, 95, maybe even a perfect 100. If that's your goal, well, you have to study everything, no shortcuts. Use this guide to make your foundation rock solid, but then you've got to go back and make sure you haven't missed a single topic in any chapter. So, I want to leave you with this. A truly brilliant result on your exam is not some far-off dream. It is absolutely within your reach. You have the roadmap now. You know what to do. The only thing left is to do it. Stay focused, work smart, not just hard, and trust this process. You can do this. You've got this. Okay, the blueprint is in your